everyone. So, secrets at scale. We're gonna discover GitHub's 9-year evolution with HashiCorp Vault, and we're gonna dive at how centralized secrets management is at the core of GitHub's operations. I'm Bogdan, my handle is Tanasie. I'm a security engineer that's part of secure access engineering at GitHub. I'm part of the perimeter and secrets team. So over the last year, I've been diving into the day-to-day operations of Vault. I also work on software and automation tooling, as well as infrastructure development. And I have a good background on how we got here after 9 years of evolution. Diving right in and what we'll cover, first of all, we'll set the stage with a bit of a background. We're gonna look at where GitHub is today, and then where we all started 9 years ago. At some point, we reached a breaking point, so we're gonna see what that is and some of the technical challenges that we faced, which led us to upgrading. So spoiler alert, we upgraded to the enterprise version. We'll see how that migration went, as well as how the evolution and the benefits and lessons learned it brought us. All right, so some background. We're gonna set the stage as where GitHub and Vault are today. So Vault at GitHub is absolutely massive. We use it as the source of truths for all our secrets. It's used by many applications. We have over 300 million daily requests that come from 55,000 active clients. We use over 68,000 secret keys, as well as 8,000 KV stores. So it's a huge scale we operate at. We have 445 secret engines, and we also use it for PKI. So I have 355 PKI set up, and many active certificates that we manage. And we use over 100K leases, and daily this system drives 500 to 600 million logs. So this gives you a bit of the sense of the scale. And you can see here, we're really scaling up to the moon. Like, this is a rocket ship. And a year ago, we were at 25 million daily requests. Now we're at over 300 million, as I said. Around February to May, we started really scaling with a lot of adoption in terms of GLB. We use Vault for actions, deployments, a lot of the critical GitHub internal infrastructure. You would think that with this kind of growth, us as an infrastructure and security team would be struggling, but you'll see in this talk that we actually are operating at a more efficient scale today, and we're doing quite well. Now that we set the stage of where we're at today, we'll go up and see how it all started. So we rewind in May 2016, where we introduced Vault for secrets management. Beforehand, we were using basically a custom internal solution, and there was a lot of secret sprawl. So we onboarded for secrets management, but quickly we saw a lot of rapid adoption in terms of PKI. We started using Vault for AWS authentication, Terraform secrets, dynamic secrets. We use it for encryption as well. So it gained a wide adoption across GitHub. At the early start, we were using the community edition, as you might think, and most people start that way. And we were on a single MySQL cluster. We went with MySQL mostly because GitHub has a lot of experience managing MySQL clusters and essentially a lot of operational expertise. So it was kind of the path of least resistance for us. However, we did reach a breaking point with our scaling, and here are some of the challenges that we faced and some limitations. So first of all, our latency, 15 milliseconds doesn't sound like a lot, but when you're scaling at such a large rate, it can become kind of a blocking point. The backups, and this is something that would keep you up at night, right? So 40 minutes to back up, 4 hours to restore, and sometimes that did not work. So we had our own custom backup solution, and in many cases, we were facing issues where the files on the system were split between in really small chunks, and with zipping, we were running into inode exhaustions on the servers. And you can imagine being in the thick of an incident, you have to restore from backup, and that fails. So we really wanted to avoid this. And also the scaling. So we're only able to scale vertically. In a 5-node cluster, for example, only the leader is able to take on a load, right? So the other 4 hosts are essentially standbys and are not active or taking any requests. And you can scale the leader as much as you want, but it doesn't scale well with a high amount of volume. So as I mentioned earlier, we moved to enterprise. Why did we choose this? So the native tooling allows us to have native integrated backups. So already here we have a backup solution that is working out of the box. We also have autopilot. We found it really useful for upgrades. Instead of manually going into the server and rebooting, we can use autopilot to essentially run the upgrade for us. We have Sentinel policies that are really useful for governance, as well as the ability to upgrade to HSM or other encryption methods that are really there for compliance. And overall, these native tools are pretty well documented. Then you have the horizontal scalability, so not scaling up, but out, and essentially using read-only replicas in our clusters. So 99% of our traffic is read-only, essentially. So out of those 300 million requests, we can serve a lot of those on the replica hosts. Then the business continuity and disaster recovery story is much better. We have the ability of having a disaster recovery cluster. We also have the option of using a performance replica cluster for performance, so that's a nice advantage as well. And the support model is nice. So we want to be able to have a partner there in times that get tough, and we've already collaborated a lot with HashiCorp in incidents and also outside. So that's a great support model for us. Now, of course, not every migration goes without its hurdles, and we've had a few, especially in terms of the initial testing. We were not able to test the migration. If I take here the Vault internal docs, you will see that for Raft, the max key size has a limit, and us working on Community Edition for 8 years and essentially building up secret, we had really big secret sizes, so we had to do some internal cleaning of the secret paths to be able to perform this migration. Once we did that part and tested it out, we had to do quite a bit of communication with our internal engineering teams, right? Because you're taking down the cluster. We wanted to log deployments and make sure we coordinate to have a smooth migration without a big impact on other engineering teams. And in the end, we were able to successfully migrate. Now, the upgrade and some pretty interesting results. So here's the Vault average response time, some big improvements here. Going from the left, you'll see the dotted purple line. That is when we upgraded and enabled read-only replicas. We are routing traffic to these replicas using anycast, which I'll dive into a bit later. But we essentially saw our response time internally within the same cluster go down from 15 milliseconds to about 7 milliseconds. So that's just the read host being able to take on traffic. If we move a bit further around December 2025, you'll see another drop from 7 milliseconds to 4 milliseconds response time. This is where we upgraded to NVMe instances, so network attached instances. Because Raft is really intense in terms of storage operations, we wanted to make sure that we have a good solution for that. We saw a lot of I/O exhaustion on the host and high I/O limits there, so upgrading to NVMe instances was another big boost for us. And then later on, around April this year, we upgraded to newer versions of Vault, so Vault 1.19, and we saw our response time go down to below 1 millisecond within the same data center, so even close to 0.35 millisecond as of now. So that's really a big progression we saw over this year alone with the upgrades we've done. At the top of this graph, you'll see some red bars here. Those are when we deploy Vault configurations, kind of a way for us to correlate with the graphs. So we have that in many of our graphs. So if there's a sudden spike and we can correlate with the deployment, we're able to troubleshoot a bit better. Speaking of troubleshooting and some incidents, you'll see some spikes in September and October. I'm going to come back to that a bit later. Those were some pretty interesting incidents we had to deal with. All right, so now looking at the response time from a client perspective. So that was within the same data center. This is around the globe as seen by a Vault client. So the lower lines in the graph, which are close to 0, would be same data center. However, you will see that in the middle, some of the European clients, and also at the top, that is Australia. So I guess you can't defy physics, right? You will have different latency depending on the geographical location. However, overall, this line is still trending downwards, and there's ways to also improve this for Australia and Europe by potentially implementing a performance replica cluster, which is something we're considering, but is also an additional cluster to manage, right? So there's a pro and con there that we're constantly exploring. But how did we do it? So there's definitely more to it. I mentioned anycast. And what is BGP, Border Gateway Protocol anycast? It advertises the same IP prefix over multiple locations, and it steers the traffic to the closest site, essentially. So that's a lot of words. From a concrete example, you would have a client and 2 instances, which are using the same anycast IP address. And how it works is your client would get routed to instance A in this case, because it's only 2 hops away. It's the closest one. And in case that instance A becomes unavailable, you would then be directed to instance B by the way the routes are advertised. The advantage we see with this is there's no load balancer in between, right? It's essentially you're routing directly to the host. It reduces the complexity. It also essentially reduces the latency. So that's one of the things that we use to improve. If we look at how it's implemented in a Vault cluster, you have the Vault leader here, which we can assume is essentially healthy because it is the leader, and then 2 replicas, one that's healthy and one that's unhealthy. In our case, you'll have a host IP address. That is unique per host, and it's used to communicate for the host to forward requests to communicate with each other, and also for essentially the RAF consensus protocol. And then you have a anycast IP address. That is what the client cares about and is used from the client side. And then in this situation, the client would get routed to replica 2, if we assume is the closest site for read requests. And then when a write request comes in, it would get forwarded to the leader. In this case, replica 3 is unhealthy, so it would not get advertised. The client could not reach or would not reach that instance in any case. But if it would come back up for some reason, it would be included in the cluster and advertised by BGP. So what improved? Well, clients, as I said, reached the nearest server. Load is distributed quite evenly from our experience. So the leader will usually have a bit more load, maybe like 30% of the load, essentially, because it's handling write operations and it gets forwarded some requests. But the replicas will also take 15 to 20% of the load, and it's pretty nicely distributed from our experience. Dead and failed servers get automatically removed, which is really nice. We don't have to change anything in configuration or do anything at the load balancer level. We use one IP for both production and disaster recovery. So that's huge, and I'll dive into this a bit more. So for BCDR, what this means is essentially we have a main cluster that uses our Vault production address, but also our disaster recovery cluster using the same. So if something happens and the main cluster is taken down, we can easily route to the disaster recovery cluster without any configuration changes. So for our client, essentially, it's transparent. You will not see anything different, right? You might get a small error for the second you're transferring or those routes get advertised, but it's almost instantaneous and without changing any sort of configuration. And then in terms of test, we also have this lone test cluster in Azure. We like to deploy all our configuration changes there first to be able to test. We're also trying out different unseal methods here. We're testing new upgrade versions for Vault. We've been also trying out comparing load balancers and how we could expose services with Tailscale instead of anycast. So that's kind of, we're always in the process of trying out new methods and methodologies and compare it to our main cluster. All right, and I did not forget about backups, right? So this was a key pain point. We went from about 40 minutes to 5 minutes to create a backup, and especially 4 hours to less than 10 minutes to load a backup. So that is kind of a big step and improvement, and we've always been able to successfully restore from backups so far. We've also driven down the actual size of the backup from 21 gigabytes to about 5 total. And this is key. We try to test these backups very regularly. We do backup restores. We also run actual production DR exercises where we'll roll over the DR to a DR cluster live, essentially, while there's traffic, and test it out, and review our playbooks and our operational methodology to make sure that if there's an actual incident, we can do this. Many times, if you didn't review your playbook, then you might get stuck somewhere, or someone else might not be able to follow it in the right way. So we try to engage as many people in this kind of BCDR process as possible. Right, so overall, we've seen 97% improved response times internally within the same cluster as Vault, a 50% reduced latency between the Vault servers, and about 40% faster unseal times as well with the improvements, and especially with newer versions of Vault, we're able to unseal much faster, and that's a really nice thing when you're rebooting a Vault server, for example. So it's nice to have that faster unseal time. Now, the evolution, and especially some lessons learned, I did not forget about these 2 spikes here that caused us some trouble. So this was in September and October 2024. We had that first spike in latency. This was caused by essentially our own maintenance operation. So we shot ourselves into the foot a bit by rebooting Vault hosts, and the unseal script had quite a low timeout. So our unsealed timed out, and it brought down our whole cluster. So hosts were rebooting one after the other until we didn't have a Vault cluster anymore. So we learned a few things from that. We reviewed our unsealing to make sure we allow for proper timeouts and also for retries. But especially in terms of maintenance, we're now looking at, do I have enough failure tolerance to reboot? If your tolerance is at 0, you should definitely not reboot. And if you're at 1, well, maybe you should think about it and maybe not take that risk, right? Also looking at, is my host a leader? If it's a leader, you should probably step it down gracefully instead of just rebooting the host and hoping for the best, right? So you can do a few things before reboots and maintenance operations to improve that, and we learned it the hard way. But actually, the unsealing times came, it was kind of a symptom of a bigger problem, and quickly after that, we had a bigger spike. So diving into it a bit further, we had data that was accumulating in the cluster around 1 million certificates that were never removed. What this was causing was the RAF snapshot was increasing in size and taking longer and longer. And overall, we had a higher index drift. So what was happening is the read-only replicas were not able to catch up with the leader, and they were going into downloading the snapshot and continuing like that. And with data accumulating and less hosts being able to serve the cluster, the leader was getting more and more pressure to a point where we started working in a degraded state. So this is a nice story where we collaborated and were on a call with HashiCorp directly, and coming back to that support model, it was really critical for us. We got some nice recommendations in terms of allowing for higher index drift at first to be able to have those hosts essentially catch up. We also increased the sizes of our hosts because with our scaling, we're kind of limited in terms of resources. And those were really tricky in that moment because we had to reboot some hosts, and that's what caused the really high spikes in latency at that time. And finally, we found the culprit. Our tidy scripts were just not running for like over a year. So it was not deleting certificates. We were not doing any sort of maintenance operation. It took around 1 day to delete all these certificates, and this is what also brought down that snapshot size from 21 gigabytes to around more manageable 5 gigabytes. So we learned a lot from this incident, and if it were not for us upgrading to an enterprise and having the 5 hosts actually taking requests, we would have been in much bigger trouble, probably faster in this sort of scenario. Now, what we learned, metrics and monitoring are absolutely key. So we started looking at the raft index drift. This is a way to essentially spot early that you're having some issues or that hosts are not able to catch up. We're also now looking at app requests coming from clients. So we've had some situations where clients, essentially our internal clients, DDoSed us or were sending a lot of requests, not because they wanted, right? But you can easily misconfigure something and then use a lot of Vault resources. So we want to understand app requests and patterns of Vault usage. Looking at leases and kind of keeping lease number down is also a key metric. The backups, as I said, so you want to make sure backups are restorable, of course, by testing them, but you also want to make sure you have a recent backup that's available. If the backup job is not running, you should probably alerting and investigating what's going on and kind of having a good story behind our backup timings and also the snapshot sizes. So if you see snapshot size increasing, maybe you should also investigate in that case. In terms of failure tolerance, as I said, if you're running some sort of manual operation or reboot operation, it's nice to check as well. And any kind of maintenance operations, so tidy scripts that are removing certificates, other sort of maintenance operations. If your script doesn't run for some time or as you expected, you should probably have some sort of metric and monitor to alert in that case. So what's next for us? Some lessons learned and takeaways is we're continuously improving. We upgraded to enterprise, but we're also trying to find other ways to improve our posture and our setup. And it's kind of like, it took 9 years, right? But we're continuously improving and finding new ways to improve this cluster. And metrics and monitoring have been key, and they've already saved us a lot of trouble since we implemented better metrics and monitoring dashboard. In terms of next steps, we're looking at upgrading to a new cluster. As I said, performance replica is a consideration and potentially improving our footprint there. We're looking at other unsealing methods, so exploring auto unseals. As well, we're collaborating with HashiCorp directly by upstreaming some changes into Vault. We have some changes for internal clients with Vault 1.21. So we're probably going to end up upgrading soon as well. And we're looking more at secrets inventory and optimization. So we're at a pretty good spot with our Vault cluster now, right? But we want to look at patterns of how secrets are used, improve our security posture, and that is only doable really if you have a good idea of where things are, when do I need to renew certificates, secrets, and kind of having a good story about the optimization and inventory. So I'm open to questions. Feel free to reach out to me here on LinkedIn, or I'll be hanging out after the chat. I hope you learned something from our 9-year evolution and can take some key takeaways to your own setup or even other engineering problems. And I want to thank my team and everyone here who was really nice and a great crowd. And I hope you enjoy your lunch and the rest of HashiConf. And thank you very much.